numpy np. Then we'll define a function j which will help us to calculate the value of loss. Now our loss function is x square plus y square plus 4x minus 6y minus 7. So it can be written as it is power of x comma 2 power of y comma 2 4 into x minus 6 into y minus 7, and then we will return this value of loss with a precision of 4 decimals. And then we'll define another function. Let that name of the function be func. It will also take two variables, two arguments as input, x and y, which will take the two variables or weights as input, and then we'll calculate the gradient of our loss function j. So as I said, gradient is nothing but the concatenation of different partial derivatives. As loss function j has this equation. So if we'll take the partial derivative of this function with respect to x and y, we'll get 2x plus 4 and 2y minus 6. So it can be written as this way: 2 into x plus 4, 2 into y minus 6. So this is the gradient of a. Then we'll use a gradient descent formula for optimization. So according to the gradient descent formula, new weights equals to old weights minus learning rate into gradient of j. So we already have a gradient of j. Learning rate, we'll take learning rate as say 0.05, and old weight something but the numpy array of a which we defined. So a new weight will be given by old weights minus 0.05, which is the learning rate into the gradient of j. And once we calculate a new weight, we'll return the new weight. Okay, and we'll first initialize a weight. Before proceeding for gradient descent process, we first randomly initialize our weights. Let's say 5 comma 5. Let the initial weight be 5 comma 5. We don't know which values of x and y will the j return the minimum value. So we'll just randomly input the values, and we'll name it as loss values. So what this will do, it will store all the loss values generated by a function j, loss function j, and then we can run our iteration. So we'll run it for 5 iterations. So first we'll print our iteration number. So we'll come to know what the number of iterations going on, and then we'll simply print the value of w1 and w2. And then we'll calculate the loss value by passing these two weights W1 and W2 to a loss function J. Once after calculating this loss value, we'll append this loss to a loss values list so that we can keep track of the loss values to see what are the different loss values for different weights. So as we'll go through the iterations, weights will change and accordingly loss will also change. So we'll have a track of the loss values. Finally, we'll calculate our new weights. So we'll pass the two weights W1 and W2 to this function which we define, which will calculate our new weights with the gradient descent formula. So this is our gradient descent formula. And then once we get our new weight, we'll feed it back to we'll update the weights. So so the first so the first weight will be W1 and second weight will be W2. Then finally we'll print our loss values, and then we'll run the program. Hope all goes well. Good, excellent. So as you can see, initially the weights were 5, 5, and as we proceed further in the iterations, the weights got updated with the help of the gradient descent formula, which is just one. And for each value of weights, a loss value was calculated. And as we proceed further in the iterations, you can see the loss values were decreasing. So this is basically how machines learn to train themselves during the training phase. And this is how machines learn to do correct prediction during the training period. I hope you found this video helpful. Don't forget to subscribe. Thank you very much.